Okay, so in this type of problem, it wants you to state if the two triangles are congruent. Okay, use a theorem or postulate to justify your answer, okay? I know on this first one the markings came out pretty light, but these two angles here were marked congruent, okay? Also, what you had in that problem was that these two angles right here are marked congruent, okay? Now, one thing I do notice is all I have is two angles marked congruent, but I can look for a common side, and yes, they share a common side. So what I have here is I have angle, side, angle in the first triangle, which is this one, okay? And then I also have angle, side, angle in the other triangle, which is over here, right? So when I'm looking at those two triangles, I would say yes, they are congruent by angle, side, angle. Now, a lot of you guys on your test, what you did wrong was you didn't say yes or no, or you didn't say the reason why, or you got the reason why incorrect. Okay, so make sure you have both parts, the yes and the reason, okay, or the no and the reason. Okay, let's take a look at number 9. Number 9, all you have here is you have a side and a side, so far we've got side, okay, and then we've got another side. Okay, is side enough information to prove triangles are congruent? No, it's not. Now, do these triangles share a common side? Are they back to back? No. Do they have vertical angles? No. So there's really not enough information here. I know they look congruent, but there's nothing that actually proves that they are because we're missing a third piece of evidence. Okay, so we're going to say no, not enough info. Make sure on the test, if it's a no, you list your reason why it's no. Okay, let's take a look at number 10. Okay, on problem number 10, okay, what you have is you have a set of sides already marked congruent. You also had a set of angles over here. Okay, one thing I do notice about this problem is we have something called vertical angles. These angles right here are the same size, these yellow ones that I'm marking. So I have an additional angle that I can use here. Okay, so now when I'm looking at this, I notice that I have in the order angle, angle, side. Okay, same thing in the other triangle, angle, angle, side. So I'm going to say for this one, my answer is yes by angle, angle, side. Okay. All right, let's look at number 11. Okay, in number 11, I've got a side. I've got another side over here. I've got an angle and an angle. So that's looking good so far. And last, I've got one more side. Okay, so this one would be yes by, we look at the order side, angle, side as we move around. Okay. Okay, let's take a look at number 12. Okay, number 12, it's looking like I've got a side. I've got another side. Now, one thing I notice is I have a common side, so I can use that one as well as the third side. So now I'm going to say on this one, yes, by side, side, side. Okay, last one right here for this set. Okay, I've got a right angle. Okay, I've got another side, and I've got another side. Now, I could look at this and say, well, this is ASS, so no, it's not congruent. However, what kind of special angle is this? It's a right triangle, so I'm going to check for hypotenuse leg. Is one of my sides a hypotenuse? Yes, this one. Is one of my sides a leg? Yes, that one. Do I have right angles? Yes. So, for my answer, I'm going to say yes by hypotenuse leg. Okay, let's look at numbers 14 and 15. It says determine whether each set of triangles is congruent using the given information. State the theorem, postulate, or reason that justifies your answer. Okay, so let's take a look at the triangles. Okay, I can prove these first two are congruent maybe by, first of all, the information they gave me up here was that angle A is already congruent to angle E, so I can mark that because it's given to me. Those angles are the same size. Now, maybe if I could show that, for example, like this side and this side were the same, and then this side and this side were the same, I can maybe try to prove using side angle side that the triangles are congruent. Okay, so let's go ahead and take a look at first maybe the short side, trying to prove those are congruent. So the short side, I'm just going to count 1, 2, 3, 4, and the other short side 1, 2, 3, 4. So yes, those are each 4. So those are congruent. Okay, now I'm going to look at side AB. So when I look at side AB, I can draw a right triangle and count that right triangle and use Pythagorean theorem because it's a slanted side. So I get this triangle's 1 by 1, 2, 3, 4, 5, 6. So I'm going to do 1 squared plus 6 squared. And I'm going to find the length of the side. So 1 plus 36 gives me 37. So on my calculator, that's about 6.1. Okay, so I'm going to go ahead and label that side 6.1. Okay, now I'm going to check DE and see if it ends up being the same. So it's 1 on that side by 1, 2, 3, 4, 5, 6. So again, I get the same numbers. So when I plug that number into Pythagorean theorem, that's going to give me 6.1 again. So I have two sides and the angle that's in between those sides because it was given to me congruent. So I have side, angle, side congruence. Okay, so when I write down my reasoning why, I'm going to say yes, they are congruent by side, angle, side. Okay, that's my congruence theorem that justifies my answer. I could also write down the supporting evidence, the 3 pieces of evidence. So one of the pieces is that segment BA was congruent to segment DE. The other piece of evidence was that angle A is congruent to angle E. That was a given information, okay, from what they gave me. And then also that segment CA is congruent to segment FE. Okay. You want to write as much information down as you can to justify your answer. Okay. All right. Let's take a look at number 15. It's given us the information already that segment RT is equal to segment MN, their length. So that means that these two sides are congruent. If those two are given to me as congruent, I won't need to use Pythagorean theorem to find their length. I can just use Pythagorean theorem to see if I can find the length of the other sides. So when I look at this other side over here, RS, I'm going to go ahead and count. It is 1 by 1, 2, 3, 4, 5. So that's going to be a 1 by 5 triangle. Okay, so I'm going to plug those numbers into Pythagorean theorem to find its length. Okay, I'm getting the square root of 26. Okay, so the square root of 26 is going to give me about 5.1. Now, I want to see if the short side on this other triangle is matching up. Okay, so when I go ahead and do the right triangle on this short side, I get that this right triangle is 2 by 1, 2, 3, 4, 5. So that's going to give me not the same number, right? So 2 squared plus 5 squared, what's that? Well, that's 4 plus 25, which is 29. Okay, so the square root of 29 gives me about 5.3. Okay, so that side is about 5.3. Okay, I'm getting right now that these two sides are not matching up. Okay, and I'm pretty sure that when I do the other two sides, okay, those ones aren't going to match up either. So since I have this set of sides not matching up already, I can say that RS is not congruent to segment ML. So the triangles are not congruent.